So now in this video we're going to add a Schmitt trigger to the non-inverting comparator. So the non-inverting comparator, when you set a voltage to the inverting input, we're just going to set 2.5 volts with equal value resistors as a voltage divider, splitting up 5 volts right there. So 2.5 volts. When the non-inverting input gets above 2.5 volts, the output goes high. When it gets below 2.5 volts, then the output goes low. It goes to ground. That's the output there. Now, for the Schmitt trigger effect, we are adding positive feedback. So that's the addition to just the normal non-inverting comparator. So you can see here, when the output is high, that pulls up the voltage at the non-inverting input right there. And so when it's high, that means we got to go down more than halfway to get below 2.5 volts because it's pulling up the voltage there. So we get past the 2.5 volts at some point, and then the output goes low. Remember, we're going down. And output goes low, and the blue LED lights up to go to ground, but also the ground there pulls the voltage down at the non-inverting input. So now it's pulling the voltage down. We have to go up more than halfway to overcome that voltage that's being pulled down. But then we will finally get high enough if this value resistor isn't too low, and then the output will go back high. So 10 kilo ohms seems to work actually pretty good for this circuit, especially for demonstration purposes. If you need more hysteresis range, you would use a lower value resistor, because then the voltage is held more coming back there because there's less resistance. If you want to shrink that hysteresis range, then you could use a higher value resistor. And so here we are on the board. The LM358, it can work with a single supply. That's what we're using now. So we consider positive supply and ground. Or you can work with positive voltage and negative voltage in relationship to ground. This is either a single supply or a dual supply op amp. We have to power it though. Again, pin 8, it goes 1, 2, 3, 4, 5, 6, 7, 8 to the positive supply. Pin 4 to ground. And we don't have to worry about the right side anymore. So there's pin 4. Then we have the output at the top, as you can see there. Right below that is the inverting input, and then right below that is the non-inverting input. Now we'll look at the circuitry. And so we got the trim pot to the non-inverting input. Let's remove this resistor for the moment, the positive feedback resistor. And then we got two equal value resistors as a voltage divider to the power supply to the non-inverting input. Remember, the inputs just look at the voltage. They don't let current in or out, other than just a very, very small trickle, practically none. And then we got the output here. So the output's high right now, connected as good as it can to positive supply. The red LED is lit up, and now it's connected as good as it can get to the negative supply, and the blue LED is lit up. You got to make sure you put the LEDs in the right way, where the long lead, the anode, is more positive, the short lead, the cathode, more negative when it lights up. So that's both of them. You can see ground's down there. That's the shorter lead. So make sure you got the LEDs in the right way. So the main thing is that right now we're just a comparator. And so when I turn the trim pot above halfway, the red LED lights up, goes high, low, just right at a certain spot right there. And so if just a slight change right in that area is a problem, that is when you get the positive feedback resistor. So we're just going to the output there and then to the non-inverting input. And now you'll see the range that we got. So right now it's low. I got to go up that far and then down that far. So this hysteresis range isn't too bad right there. But you can see I have to move through that area. There's no defined point where it just bounces back and forth. And just in case you have a hard time seeing, I'll zoom back. So we're already high, low. You can see this range, I got to go before the output will change. So that is the point of that. Again, if there's a fine line where your input might jiggle a little, but you don't want that jiggling to change the output, you want to have to go over a range, a hysteresis, before it will change. That's all you got to do. Positive feedback with the op amp. Really easy. So in any case, hope you enjoyed the video. Make sure you check out one of the other videos I'm posting to the screen. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. But just watching videos helps out a ton. Thanks to everybody that watches them. I'll see you in the next video.